All right. I promised you that we would do this. This would be the next video, and here it is. It's not part of the general lecture notes, but it is still important, and it's going to be a breakdown of some of that data. We're going to talk about that climate change. We're going to talk about that data. We're going to really dig into what the problem is. All right, so the history is the Mauna Loa Observatory. It's really important for us to understand the history behind Mauna Loa before we actually look at the data, even though you've already seen some of the data. Now you're going to understand it a little bit more. In 1958, Charles Keeling began to monitor and collect data related to atmospheric change at the Mauna Loa Observatory. Specifically, he wanted to measure CO2 levels. Mauna Loa is Hawaii. The result has been data collected for over 60 years that directly measures CO2 levels, and it's become commonly referred to as the Keeling curve. Currently, the Mauna Loa Observatory is under the Earth System Research Laboratory, which is part of the National Oceanic and Atmospheric Administration, the NOAA. And we're going to look at some of that data. We're going to look at some recent data. So I hopefully will update this video every year. That's the goal, right? So this should be very relevant and new, which means we're going to talk about something new, which is kind of interesting. So let's do it. Here's some monthly, and this is just looking at daily numbers. That is what they created averages with, because they don't check it every day. The most recent reading that I wanted to pull from was January 30th, 2021. I could pull data from earlier, but this is part of this data set, and that's the most important part. It was 415.75. So if you remember from the video, when it was August 2020, we were looking, or sorry, April 2020, we were looking at 417. So we're right about the same level, and that's interesting, to say the least. Except you're going to see a trend that shows that it's not as abnormal as possible. So you can see, overall, it's been all over the place. From 415.5 all the way up to 419.5. This is obviously 415.75 is right here. That's the official data point that they put in there, right? Our today's data is like 417.8 or something like that. Today is actually the 15th, so we're over here. But whatever. You can see that these data points fluctuate every day. They fluctuate. So we're not really seeing a whole lot. We're not seeing much of a trend. We can see a trend that it's kind of going up, and that's troubling. But is that really a trend? We're only looking at 2 weeks of data. So now let's break it down and look at like just the last month. Okay. Now it's starting to get a little clearer. There is, in fact, a clear rise from way back at the, in January 15th-ish, all the way up to today. We do see a trend line working its way up. These, based on the data we're seeing right now, I would call these outliers. What if we were to go back even further? What if we went back like the past 6 months? Now we're gonna get busy, right? Wait a second. If we look back the past 6 months, there's a trend that started in October going up, but it seemed like it went down here. You notice that curve down? That is suspicious. Maybe it's not a problem. Like right now we're at levels right here, but is that a bad thing? Because it looks like, based on this graph, I bet you we were at levels like that a year ago. Let's look. So this goes all the way back to last April. Remember last April? Wasn't it beautiful? Super interesting. We're going to talk about this in a second, but you're starting to see this fluctuation. Like it just goes up and it goes down and it goes up and it goes down, I bet. So we're at a high point. We're at a peak, right? The problem is when we were at this point a year ago, we were in the 413 to 414. And right now we're in the 417 to 415 area. That's not good, but maybe it's just a fluctuation. Maybe this year's just a little weird. This point right here is super interesting to me. This actually makes me very excited about the data because what happened right around here? Lockdowns, right? A lot of lockdowns, a lot of changes because of the global pandemic. And you can see that everything was starting to drop. And so they were looking at the data. You can imagine if I cut everything off after this point, they were looking at this data and saying, uh-oh, things are actually changing. And then we did what we normally do, and we brought those numbers back up like we do. So let's go back. That's 1 year. Here's the past 2 years. Again, we can see the data here. We're seeing this peak in May, and this dip in October, and another peak in May, and a dip in October. Right now, we're at 415. We're at 417 today. which is around the peak average area from last year. The problem is it's February. We got, what, 3 more months until we get to the May peak? That's unfortunate. This is where the data really gets interesting. We see these fluctuations, and you saw it in the last video. We talked about why these fluctuations happen. It has to do with a lot about the changing weather, the ability for all of that vegetation in the northern hemisphere to absorb more carbon dioxide, which brings these numbers down. So if someone were to say, just show you this data, they said, hey, look at this data from, June of 2020 to October of 2020. This is carbon dioxide data from June to October in 2020. And they just showed you this part right here. What are they showing you? They're showing you a misrepresentation of the data, because if you just looked at this, you'd say, holy cow, we're doing a good job. We're solving the problem. The problem is every year we have that dip. Every year we have this dip as we enter into summer. And then as we go into the winter months, we see the rise. And the peaks are always higher than the last year. So we are, in fact, adding more carbon dioxide to the atmosphere. We can see the data that we're adding more carbon dioxide in the atmosphere. Maybe it's not us. Maybe it's not humans. Who knows? But you know what? There's a clear data point that we can see that atmospheric CO2 is, in fact, increasing year over year. So let's look at all the data. This is the full record, right? The full record from 1958 all the way to now. And if we look at the trend line, we see the trend line is definitely increasing. When they started taking these readings, they were in the 315s, and we are already 100 parts per million higher than that today. There's no denying that this is an upward trend of carbon dioxide in the atmosphere. This is all the way back to way back when, right? All the way back to 1700. So the beginning of the United States history. Where does all this data come from? This stuff right here comes from ice core data from before 1958. And we'll talk about ice core data a little bit in class. If we don't, I'm going to talk about it right now. Ice core data is essentially where we're able to dig a core into an ice sample up in like the northern hemisphere or the southern hemisphere. We find a big area with ice. We dig a deep core into it. And inside of that core, there are these little pockets of gas. And those pockets of gas actually are what was in the air that time. So we're able to tell based on the year, because every year snow falls, melts a little bit, turns into ice, more snow falls on top of that the next year, ice, more snow. So we can actually measure the years, and we can take, okay, we pulled this bubble out from, 1900. We can see how much carbon dioxide was in the atmosphere at that time. So we can take this data to extend our curve. And we can see that when we started measuring the data, that's when we start to see the hockey stick, right? Where we start to see this serious increase, flattening over here. We can go back even further with ice core data. We can go back all the way to 10,000 years ago. And this is where things start to get a little interesting, because now it's hard to deny that humans aren't the problem, that humans aren't the ones adding that CO2. Because yes, humans have existed for all of these times, but what happened right here? What happened right in here, right in here, when we started to see this dramatic increase, this curve, exponential up? Well, that's the Industrial Revolution, guys. It's hard to say that we are not the cause of the CO2. So let's go into more depth, right? We can go back even further. 800,000 years ago, we see these normal dips and rises in CO2 levels. Normal, natural. Not as natural. We have a huge increase right here. We have a huge increase, and that is not ideal. That's where we can say, yeah, it's not probably a natural thing, because naturally over the last 10 or 800,000 years, there have been these natural increases in CO2 in the atmosphere. But we are seeing this spike, and we can directly correlate that to the beginning of the Industrial Revolution, when we started burning fossil fuels. It's hard to say that CO2 increases are not human caused. So who cares? It's just CO2, right? We talked about CO2 before, right? Didn't we? Doesn't CO2 cause climate change? Doesn't CO2 increase the global temperature because it is a greenhouse gas? Yes. Average global temperature from 1880 to 2013 is also rising, and that's not good. We can also look at data from historic data all the way back. So here's, 2000, year 2000, 1500, 1000, 500. These all came from proxy-based reconstruction. So there's a little level of uncertainty, and that's why you see all of these little areas of green shadow. We'll talk about proxy-based versus instrumental data in our next video, but that's where this data comes from. This is temperatures, right? We're able to look at proxy data. Again, we'll talk about that in a minute. And this is how we can reconstruct what temperatures looked like all the way back to 500. We can also do the same thing to look back to 800,000 years ago. Remember when we looked at the CO2 from 800,000 years ago? Don't you see a direct correlation between the two pieces of data? Well, let me overlay it for you. This is the CO2 rating all the way back to 800,000 years ago. This is that beautiful graph of temperatures. And if I overlay those two sets of data, isn't it kind of hard to say that they're not related? Isn't it difficult to say that global climate warming is not directly as a result of CO2 level in the atmosphere? I dare to say that it is not hard to make that relationship. Causation is not correlation. Well, correlation is not causation, that whole thing. But guess what? We have data that can go back 800,000 years that shows carbon dioxide levels and temperatures are so closely intertwined. We've also looked at the science of why they're intertwined. It's a greenhouse gas. It captures and holds more temperature. So you now have some data to argue climate change with the people that say that it's not real, because that's not the problem anymore. The problem isn't that it's real. It's real. The problem is, how do we solve it? Last little piece of fun for you. What is more likely? The regional environmental groups and community activists are spending a small amount of operational budgets in a massive conspiracy with 90% of the global scientific community to create a hoax and ruin the economy. Or is it oil companies spending their obscene profits to bribe anyone that they can to protect their profits and limit any future liability that their pollution might cause? Interesting little perspective here. It's pretty tough to say that when we look at these scientists, they're probably not on the right side. I would say that they probably are, because they, just like you right now, have seen the data.